Okay, so here's number 6. The original question is in red, 1 over root 7 plus 1 over root 2, and I have to simplify and rationalize the denominator. So what I've done is, because we know with two fractions when I add them and they've got different denominators, I've got to get a common denominator. So I've times this one top and bottom by root 2, and I've times this one top and bottom by root 7. Why have I done that? Because that gives me a common denominator of root 2 times root 7. They're the same. So now I'm going to go ahead and simplify that top line. So I've got root 2 times 1. That gives me root 2 right there. And I've got root 7 times 1. That gives me root 7 right there. And what have you got on the bottom? Root 2 times root 7. Which is also, there it is there, but I could also write it as root 14. That makes it a much simpler expression. So far I've got to this stage here. Now, what am I doing here? I'm rationalizing the denominator. Why have I picked root 14 over root 14? Because of what's down here. I need to rationalize that one. So we go ahead and times top and bottom by root 14. And let me just move this up. So that gives me on the top root 14 outside of root 2 plus root 7. And on the bottom, this root 14 times this root 14 gives me 14. Now I could stop there, which is why I've given it a big tick. But you can keep going. So to keep going, I'm going to expand it out. Root 14 times root 2 is root 28. So that's root 14 times root 2 is root 28. And then root 14 times root 7 is root 98. And we can keep going with that too, because root 28 has got a nice perfect square sitting in it, because 4 7s are 28. So let's do that. So 4 times 7. Now what am I going to do with the 98? The 98 is 49 times 2. And 49 times 2 is great because 49 is a perfect square. So let's keep going. Square root of 4 is 2. The square root of 7 stays behind. Plus square root of 49 is 7. Square root of 2 stays behind, and that's all over 14. And you're done.